The IP protocol delivers a packet from a source host to the destination host. For that, it needs to know how to deliver it to the next hop first. An IP packet can consult its routing table to find the IP address of the next hop. But since IP uses the services of data link layer, it needs to know the physical address of the next hop. This can be done using a protocol called Address Resolution Protocol ARP. So to understand the ARP completely, watch the video till the end. As we know, the unique logical address is used to recognize hosts and routers globally. The logical addresses in the TCP IP protocol suites are called IP addresses. However, packets pass through physical networks to reach these hosts and router. At the physical level, the host and routers are recognized by their physical addresses. It should be unique but not necessarily globally. It is called physical address because it is usually implemented in hardware. Example of physical address are 48-bit MAC address in the Ethernet protocol, which are imprinted on the NIC installed in the host or router. The delivery of a packet to a host or a router requires two levels of addressing, logical and physical. We need to map a logical address to its physical address and vice versa. This can be done using either static or dynamic mapping. Static mapping means creating a table that associates a logical address with a physical address. This table is stored in each machine on the network. Each machine that knows, for example, the IP address of another machine but not its physical address can look it in the table. This has some limitations because physical address may change due to change in their NIC. A mobile computer can move from one physical network to another, resulting in a change in its physical address. To implement this change, a static mapping table must be updated periodically. In dynamic mapping, each time a machine knows a logical address of another machine, it can use a protocol to find physical address. We use protocol for dynamic mapping called Address Resolution Protocol ARP. ARP maps a logical address to a physical address. Anytime a host or a router has an IP datagram to send to another host or router, it has the logical IP address of the receiver. But the IP datagram must be encapsulated in a frame to be able to pass through the physical network. This means that sender needs the physical address of receiver. ARP accepts a logical address from IP protocol, maps the address to the corresponding physical address, and pass it to the data link layer. Suppose system A has a packet that needs to be delivered to another system B with IP address 141.23.57.24. Here you can see each system maintains the ARP table. System A needs to pass the packet to its data link layer for the actual delivery, but it does not know the physical address of the recipient. It uses the services of ARP by asking the ARP protocol to send a broadcast ARP request packet to ask for the physical address of a system with an IP address of 141.23.57.24. This packet is received by every system on the physical network, but only system B will answer it based on its IP address. Now, system B ARP table saves the sender IP address and physical address in ARP table for future use and sends an ARP reply packet that includes its physical address to system A. Now system A knows the physical address of system B, so it makes the entry of the physical address in its ARP table. Now A can send all the packets it has for this destination using the physical address it received. So we can say an ARP request is broadcast while an ARP reply is unicast. If you want to see the ARP table in your computer, you can simply write ARP-A and you can see how all internet addresses map to physical address in your networks. So I hope you understand how ARP works for mapping of logical address to a physical address in computer networks. See you in next video. Till then, bye bye. If you like this video, press like and subscribe the channel and share the video. And don't forget to press the bell icon for my new video notifications. Thanks for watching.